So in this video we're going to use our free body diagram to make equations and solve for our force of friction. And this takes advantage of Newton's second law, which states that the net force on an object causes the object to accelerate. So we'll start by analyzing our the net force on our first object, object 1. And you need to know that, again, F net on 1 equals m1 times A. So the net force on 1, I'm going to make a net force equation. And when I make a net force equation, I analyze all of the forces that are in that same dimension as that net force, and I build from there. So I see with my net force 1, I have tension. That's in the same direction. It's totally parallel. And I have the force of gravity that goes down the ramp. That's my parallel component of the weight. It's anti-parallel, but it's still in the same dimension. And then I have the force of friction. So I'll show you how to build this equation. F net 1 equals tension, and because tension is in the same direction as this F net 1, I'm going to write it as a positive T on this side. And then I have the parallel component of weight, and it's opposite to the net force, so I give this a negative sign, minus W parallel. And then I have the force of friction down the ramp. It is also opposite to the net force, so this becomes minus F of F. And now, because according to Newton's laws, if I have these net forces, then I'm going to have an acceleration acting on mass 1, so I'm going to rewrite this as m1 times A equals tension minus weight parallel minus the force of friction. Now I'm going to analyze the forces acting on the mass 2. Same thing, F net sub 2 equals mass of 2 times A. This is Newton's second law. And so if I look at my net force, I can see I have two forces that give rise to this net force on 2. I have tension and I have the object's weight. So I write my net force equation, F net sub 2 equals, the weight is in the same direction as F net 2, so I write this as a positive W sub 2, and tension is opposite to my F net 2, so this is negative tension. And in accordance with Newton's second law, I know that these vectors give rise to an acceleration, so I'll rewrite this as m sub 2 times A equals W sub 2 minus T. Look at this. Tension, tension. Tension equals tension. These two objects are connected. This string experiences the same tautness all along. So I'm going to set each equation. I'm going to solve for tension in each equation, and then I will set both of these equations equal to each other because tension equals tension. So from here I have tension equals W sub 2 minus m sub 2 times A. And over here I will rewrite this as tension equals m1 times A plus parallel component of weight plus force of friction. Now tension is tension, so we'll set these two equations equal to each other, and we get W sub 2 minus m sub 2 times A equals m1 times A plus parallel component of weight plus the force of friction. And this force of friction is what we're trying to solve for. So let's go ahead and solve for it. Force of friction equals my weight sub 2 minus m sub 2 times A minus m1 times A minus the parallel component of weight. A lot of negatives. Okay, now let us remember, to get the parallel component of weight, we need to analyze this triangle. It's a right triangle because this component of the force of gravity and this component of the force of gravity are perpendicular. And if I remember from my trig functions, I have an angle which is equal to this theta. I have a hypotenuse, which is the force of gravity, and I have an opposite side. Angle, hypotenuse, opposite. Opposite, hypotenuse. That's a sine function. So sine theta equals opposite, which is this parallel component of weight, divided by hypotenuse, which is the force of gravity itself, weight sub 1. So now to get this parallel component of weight, I will write this as parallel component of the weight equals force of gravity acting on object 1 times sine of theta. And I can substitute in for this. So my force of friction equals weight sub 2 minus mass 2 times its acceleration minus mass 1 times its acceleration minus weight 1 times sine theta. Okay, so that's how we're going to solve for it. And once you have your accelerations your acceleration from tracker, you can plug this in and solve for your force of friction. I hope you found this video helpful. Thanks for watching.